Okay, so today we're going to go over symmetry. More specifically, we're going to go over how to identify if a specific function is odd or even. So again, today the words to know, being able to differentiate between an even function and an odd function. But before I do that, I want to go over some types of symmetry. So we have line symmetry, which basically means that if you take a figure or a graph and reflect it or flip it over a line, the picture is going to look the exact same. So this is the type of symmetry that we know more often. So basically, if you take a piece of paper and you split it in half, you would create two symmetrical halves. And so that's kind of what line of symmetry is. We also have what is known as rotational symmetry. And rotational symmetry is when we can rotate something about a point and make it come back to its exact same figure. So this is the type of symmetry that we aren't so familiar with. And so I want to go ahead and show you what it actually looks like in case you aren't 100% sure. So let me share that. Rotational symmetry. Okay, so basically this is what rotational symmetry is. So you spin something about a point, and whenever it maps back onto itself, that is what we consider rotational symmetry. And so I'll show you again. So those things are rotating about that point, and when they map onto themselves, we can count that as one-time rotational symmetry. But the reasons that this is important is not necessarily being able to differentiate between the two, but rather know that these things apply whenever we have an even or, that's not what I want to do, an even or an odd function. Okay. So again, that's line symmetry and rotational symmetry. And so what does this mean? Well, we're going to see that we have specific line symmetry and rotational symmetry that correlates with even and odd functions. And so line symmetry with respect to the y-axis. So basically what that means is that we reflect something over the y-axis. The y-axis being this axis right here. Okay, so as you can see, it kind of looks like we reflected that line over that axis to create that other line. And as a result, for every xy point on the line, the point negative xy has to also lie on the graph. So basically, this is what we get for an even function. So whenever we have line symmetry, we have what we know as an even function. And we know this is even, and this is how we're going to be able to differentiate between if something is even or something is odd. If it is even, then our original xy will map to negative xy. And so what does this mean? Well, let's look at these points on this graph. Here we have 2 and 4. So that's our original xy. So we have 2 and 4. Well, when we do that line of symmetry, what we get as a result is negative 2 and 4. And what we can see there is the only thing that changed was x. X becomes negative. And because x becomes negative and the y stays the same, we know we have an even function. So if even, then x will become negative and our y's will stay the same. Okay, so that's how we're going to be able to differentiate between an even and later we'll see an odd. So that being said, what we can go ahead and do is see if certain functions are in fact even functions. And the way that we do that is we plug in a regular x value, such as 3, and its opposite or its inverse, negative 3. And so I'm going to show you what this means. So here we have a function. We have x squared. And so we want to see if x squared is in fact an even function. Well, the way we're going to do that is we're going to plug in first our regular x. So it becomes f3 equals 3 squared. 3 squared basically just means 3 times 3. And so we get 9. So that means that our x value was 3, and as a result, we got our y value 9, okay? But how do we check if this is even? Well, to check if this is even, we need to put in the negative x value. So instead of 3, we're going to put negative 3, negative 3, 2. What does this mean? Well, this means negative 3 times negative 3. A negative times a negative equals a positive, and so we get 9. And so we can see that what we did there, what was it we got? A negative x, but we got the same y's. And so because we got a negative x and the same y's, we were able to satisfy this statement. And so what does that mean? Well, that means that if we're asked, is this function even? Well, then we can say yes. Why? Well, because we got the negative x and the same y. Okay? Any questions so far? Questions? Okay. And so let's go ahead and try another function. We want to see if this function is even. Well, what do we know to test if something is even, if the function is even? We need to take the original x and its negative. So we're going to plug in positive 1 and negative 1. So let's try positive 1 first. Okay. And so 1 minus 5, oops, yeah, 5 plus 1, which will give us negative 3. So what did we get? We got, whenever we put in a positive 1, we get negative 3. Now let's try our negative 1. So you have 1. What does this give us? A 7. And so when we put a negative 1, we get a 7. So now we're asked, is this an even? Well, let's see. Do we get a negative x? Yes, we do. But do our y values match? No, they do not. So because our y values don't match, we can't satisfy the criteria for something to be an even. And so because of that, if we're asked, is this even, we can say no. Because in order for it to be an even, we have to get that negative y. But whenever we put in a negative y, we have to have the same y values. And in this instance, we do not. We have a negative 3 and a 7. Okay? So any questions about this?
No, ma'am.
No? Okay. All right. So we also have something that is known as rotational symmetry. And like we said before, rotational symmetry is basically spinning something about a center point until it maps to itself. And so what we notice here is something kind of different from line symmetry. And what we see is that we take our original x and y, and it actually becomes negative x and negative y. So this is what we get as an odd. So if odd, x and y will map to negative x and negative y. So let me show you what this means. Here we have a 2 and an 8. And when we do rotational symmetry, we get negative 2 and negative 8. And whenever we do rotational symmetry, that is what we know as an odd function. So it's basically going to be the same thing as even, but when we test it, what we want to do is we want to make sure that we're getting the negated version of that y and the negated version of that x. And so if we get the negated version of our y and x, well, then we know that we have what is known as an odd function. And so let's go ahead and test this out. So very similar, but now we're going to test if this function is odd. So I want to know, is this odd? So I'm going to put in my original x, my positive x, and I'm going to put in my negated x like I did before. So I'm going to try my positive x first. And this gives me 8 minus 20 plus 4. And when I do that, I'll get 12 plus 4. Simplify that further, I get, negative 12. Negative 12 because I'm subtracting 8 divided by 20, so that gives me negative 12. And so that results in negative 8. So here I put in a 2, and I got out a negative 8. Okay, so now let me go ahead and test my negative 2. Okay, when I do that, that gives me negative 28. 4. What does that give me? That gives me negative 32. And so when I put in a negative 2, I get a negative 32. Okay, so now I'm going to see, is this an odd? Well, if it's an odd, then it has to satisfy this statement. So if odd, my x and y will change and be mapped to negative x, negative y. And so here I have my original x did change to a negative y, okay? But here I have a negative y that changes to another negative y. Well, because my y's aren't opposites of each other, it's not 8 and negative 8 or 32 and negative 32. Because they're two totally different numbers, what I can take from that is these are not, in fact, this is not an odd function. So if I'm asked is it odd, my answer would be no. In order for it to be odd, my coordinates would have to map from original xy to a negative x and negative y. Okay? Any questions about this?
No, ma'am.
No. Okay. So what did we learn today? Well, we learned that an even function is symmetric with respect to the y-axis. So basically, it follows what we know as line symmetry. Okay. And we learned that in order for something to be an even function, we have to take our original x, y, and make it negative x and negative y. So for example, if I know that I have a function that has the coordinates 3 and 7, if I needed to get coordinates that were in fact even, I would have to do negative 3 and 7. Why? Because my x has to change to a negative, but my y has to stay the same. And so that's my characteristics of an even function. Okay, another example might be 4 and 8. Well, let's say I wanted to create the coordinate that is even. I would put negative 4 and 8. Why? Because my x has to change to a negative, and then my y's have to stay the same in order for it to be even. And so that would be an even function. Okay, what about odds? Well, we learned that odds deal with rotational symmetry. Sorry. But we learned that odd functions are a little different. For example, if I start with 3 and 7, like I did in my even, in order for something to be odd, I would have to end with -3 and -7. So both of my functions need to go from positive to negative. So in this instance, this would be a odd function. Same thing goes if I start with 4 and 8. If I needed to create a coordinate which was odd, I would just have to negate both of my original x and y's, and so I get -4, -8, and so therefore that would be odd. Okay? Any questions?
No, ma'am.
Okay. So basically what you want to do to determine if something is even or if something is odd, first I'll start with even. So if you want to determine if something is even, you're going to put in the value it tells you to put in for x. So say it tells you to put in 3. But you need to know that what you also need to do is put in the opposite. So you also have to put in -3 into that function. So first you'll test it with the regular 3, +3, and then you'll test it with the -3. And what you're testing for the even is to make sure that you get the same resulting value. So you have to get the same y. And if you get the same y in both instances, then that function is going to be even. For odd, on the other hand, you do want to put in that +3, for example. And then what you want to see is what you get. So say you get a 9. Then you're going to put in the negative of that 3. So you're going to put in -3. And what you're going to want to get is a -9 because you need to get a opposite of your resulting function. And so that's how you'll be able to determine if a function or if an equation that you get, equation and function are one and the same, are even or odd, okay? But again, we'll go over some examples tomorrow so you can see what kind of question types you'll get, and then you'll be able to do some on your own, okay? Any questions? Okay. If there's no other questions, you guys may log off, and I'll see you guys tomorrow. Bye, guys.
Bye, miss. Have a good day.
You too. Bye.